The next technology that is coming on board is concentrating photovoltaics. So basically what that is if you take, instead of a panel that you see on the roof, you take a much smaller piece of silicon, a much smaller cell, and you concentrate the power of the sun on that one small cell. And you get much more bang for the buck that way, but you've got to be able to move those units with the sun. You've got to be able to track them on two axes to be able to make sure that it's pointed at the sun. So it's a different technology. You can harness the power more effectively, but it's more complicated and more expensive. The next slide is concentrating solar thermal. That's taking the power of the sun, producing heat to heat a transfer fluid. In the lower left, you see rows of parabolic solar panels that are heating in a concentrated way a central tube that includes heat transfer fluid that is then cycled through a heating system that makes steam to power a turbine. So in this example, solar power isn't really taking the sun's energy and making electricity. It is taking the sun's energy, heating the water to turn a turbine. Next, the largest example of that is being built right here in Arizona with APS and Solana. Solana is the name of the project with Abengoa, a Spanish company. They're about 70 miles southwest of Phoenix. They'll be producing a plant that is able to produce enough power to serve 70,000 homes. It is a huge undertaking. One of the issues with solar is certainly the intermittency of the power. The sun isn't up 24 hours a day, so when the sun isn't up, you've got to be able to store that power. And in this plant, in this technology, they will be storing the energy in molten salt. They'll be transferring it into heat and storing it in a molten salt facility to then use it 6 hours later in terms of recycling the heat energy. So it's a very great opportunity for Arizona to show off this technology and to become just another jewel in our crown to show our leadership in this position, thanks to APS. The second generation, the next slide, second generation of photovoltaics is thin film technology. And basically that's taking materials other than silicon, silicon is basically the element that's used in traditional first generation PV, looking at other materials that can be used to produce very thin, long panels that can be used in commercial applications. It is the kind of thing that is less expensive, but it's also less efficient. The traditional power photovoltaic panel is about 15% efficient. These technologies have a little less efficiency, but they're cheaper. They're great for commercial applications. First Solar, one of our leading companies in Arizona, right down by ASU, is one of the leaders in production of thin film technology with a market mostly in Europe. The third generation of solar energy will be in the molecular level, where we're looking at nanotechnology to produce structures on a molecular level that can be used to emulate the semiconductor material that we find in silicon and other resources that are in the second generation. If we can produce this, then we can raise efficiencies to about 50% at a much lower cost than producing photovoltaics in first generation or even second generation solar technology. This is the guts of most of the research that's going on today to try to find solutions that we can build on a molecular level, creating materials and structures that can be used in very high efficient ways. This is years off before it's commercially available, but it's the current wave of advancement of the technology in solar. The reason for the jet plane in the first slide was that we consider everything having to do with transforming solar energy into power to be solar energy within ASU. So here we are experimenting with what's called Tubes in the Desert. It's a partnership with BP at our Bar Design Institute, where we are taking specially engineered bacteria, putting them in tubes of water, feeding them carbon dioxide. The bacteria grow quickly, produce lipid, which is a fat, which is then mined and taken and produce diesel fuel. So if we can take common bacteria and give it poison, CO2, basically the greenhouse gas poison, maybe extracting it from a power plant in the process of them creating carbon dioxide, then we can use that process to produce fuel and jet fuel. We also have one other research project going on in algae, using algae, I should say, at our college campus. Same kind of idea, where we're taking algae and having the sun shine on those tubes that are in the center box there to produce lipids, to produce biofuel as well. So when we think of solar, we think of many more things beside a rooftop panel. And there will be advances in all of these areas that will help us take the most out of the sun and use it to our advantage going forward. Well, it's hidden there, but it's what is ASU doing in solar? So that's a primer on solar. That's basically what's going on in technology. Now, what are we doing at ASU to advance all those things? I mentioned briefly the Biodesign Institute in the lower right. There are all kinds of other things going on at ASU that are represented in those pictures that I will speak of individually. But I wanted to say before leaving this slide that ASU is one of 3 universities in the country that received more than 2 of the Solar America Initiative Awards from the DOE. MIT was one, I can't remember the other. We are advancing the technology in solar above and beyond most every other university, and we are dedicating ourselves to this industry and to sustainability generally with the first school of sustainability in the country and with the programs that we have going on in research as represented all around that map. So the first thing that's shown there, but I'd like to show another slide for, is the solarization of our campus. We're putting our money where our mouth is. Actually, private industry is putting their money where our mouth is to help us put solar panels throughout our campus on Tempe. We have almost 2 megawatts today. There's a picture of the parking garage across from the football stadium that is now covered in solar panels. They do 2 things. They help shade the cars and they produce electricity. We get about 7% of our power needs from that installation. We will be growing our installations at ASU in Tempe to 10 megawatts, and later through the West Campus growing to over 40 megawatts. Okay, so that's one element of our leadership position. This is another. We are the lead university among 13, including Georgia Tech and others, in terms of studying the impact of power generation introduction in the grid. The grid is viewed in a multi-state regional way. There are power lines that exist today that can take additional generation of power, but when you do that, it impacts the whole grid. And you can't simply put a generation plant within the grid and say, I think the electrons are going to go from here to there. The grid acts almost like a river. You put power into the grid and it goes every which way because of the demand within the region and because of the capacities of the system and because the system is either up or down in various locations. What this center does is study what will happen when additional generation sources are added to the grid. And it takes all those things into account, it models them, and can help us decide what to do in terms of the most optimum use of new generation sources within the grid. So we are the lead in that, and it's a national effort. We also have the country's only testing lab. We recently merged our facility with TUV Rhineland, which is one of the largest testing companies in the world. Relocated our facility to south of campus, and we're conducting our business there as the leading testing organization within the country. Everyone who has a panel has to go to one of 3 in the world testing labs. We have one. Another example of our leadership position in this total industry. The next slide shows something that's a little bit off.